guys, what's up? We're back at the AAUS annual symposium with one of the scientists that attended. This is Joe Cool, clearly one of the coolest guys here. And I just wanted to ask you a couple of questions, if that's okay.
Yeah, absolutely.
So Joe, you work for Mote Marine Lab, yeah?
Yeah, Mote Marine Laboratory and Aquarium. So I'm based in Summerlin Pool, down in the Florida Pool. We've got multiple facilities. I'm the diving safety officer for us in the Keys. As well as a staff biologist in there. Running boats every day, outlining coral, monitoring coral.
Cool. So you are the dive safety officer for Mote in the Keys, and you kind of oversee general safety precautions and stuff like that for like the coral restoration that's going on out there.
Yeah, so I handle all the paperwork of anyone diving on staff or visiting divers, volunteer divers, everything like that. And then whenever we have other organizations that come down and want to dive with us, I'm the one that handles all that paperwork.
Oh, okay.
And then I also get to go out diving with them.
That was going to be my next question.
Yeah.
Do you actually get to go diving?
So 2023, I did 550 dives. So I'm on the water pretty much every single day.
Yeah. So are you working on, you're doing a lot of paperwork and all of that. Do you get to work, in the labs with the corals, or is it mostly just safety and paperwork for you?
So I'm only on land whenever the weather's not good enough to get us out on the boat, and that's when I kind of do the bulk of any other paperwork. But I mean, in the summer we might go 3-4 weeks where I'm just on the boat Monday through Friday every day, and then I just do a little bit of paperwork in the evening or whatnot. But yeah, I mean, it's not like my job is mostly to go out on the boat and do field work. And then dive safety, and I mean, obviously safety is a priority, but that gets done after the field work gets done.
And can you talk about the field work at all? Like what you guys are doing out there?
Yeah, so we have 2 coral nurseries in the lower Keys that I'm on and manage. One of them is about an acre in size. That's near New Key. It's just inside of there. We got one off Key West as well, so a little bit smaller. So we're growing coral out there, managing the genetic diversity of the coral out there on the nursery. So we're building the structures for that. We're fragmenting the coral out there. We're outplanting that coral, and then we're monitoring the coral as well. And we monitor it.
So you guys are also, if I'm not mistaken, you guys are, I guess the word breeding coral?
So we have like a coral reproduction team.
Okay.
So we facilitate a lot of the work that they do. So we've set aside some structures in our coral nursery that's in the water, and we let the corals grow a little bit bigger so that they can get to spawning sizes. And then when spawning season comes around for that species, we can bring them into the lab, and they're held on site, and then they spawn on site. You can isolate what genotypes of each coral there are, and then we can do selective crossbreeding to make future corals that might be resistant to more things than their parents are.
Right. So just like we did with tomatoes, right? We made them resistant to certain pesticides and herbicides and stuff like that. Yeah.
So we can get the goal is to get thermally tolerant, disease-resistant corals. So by taking selective traits and different parent colonies and crossbreeding, and then seeing how those recruits do out in the nurseries, in our raceways on land or out on the reef, we can see which ones do better.
I'm curious to know, so how much of it is really guesswork? Or do we really have it pretty cut and dry? Like we know, because genotypes and phenotypes are different things, right? As far as how they're expressed. Yeah. So you may have the right genotype for it, but they may not express those.
Right. Yes.
Great.
Yeah, exactly. So a lot of it's just going to be experimental based on how much we outplant. And traditionally, outplanting is just based on whatever grows the fastest. So it might not be the best for disease and heat resistance, but if it grows a lot faster, then we're going to have a lot more of that. And so we outplant basically based on how much material we have. But since Mote has been outplanting for so long, and we keep track of it meticulously, we're able to go back and we can look at data, survival data over the history of outplanting.
Okay.
And even though we also run experiments in the lab to see which genotypes do better, but we can also compare that with our outplanted data to see how that works.
And how long have we been doing this as far as how long have we been planting corals?
So I started with Mote in 2019, and I know that's when Mote really started an exponential increase in 2018, 2019.
Now, we also recently got lab-grown coral to spawn in the wild. Is that true?
Yeah. So Mote we've outplanted some corals that we had fragged on land. We outplanted them on the reef. Because normally it might take a colony 20, 30, 40 years to get to the size where it can spawn.
Yeah, and so for the people that don't know, when we're talking about fragmenting coral and planting it, right? essentially, I forget the person's name that said, well, the problem is that we can't grow a 50-year coral in 10 years. Somebody else said, oh yeah, watch this. And we fragmented some coral and realized that if we stress it, and then we put the same genotype close together in a spacing that makes sense, that it will in fact grow a 50.
Yeah, so by taking a single colony and cutting it into a bunch of little pieces, they're all genetically identical, so they'll fuse back together as if they were one.
Right, so
yeah, so we can
spread it
take a
out.
big colony, and then we can split it up into a couple of different colonies, and then just have them spaced out. And right after they're cut that small, there's rapid regrowth of tissue right after that fragmentation process. So you can get that rapid growth.
Kind of like when you touch your skin, right?
Right, yeah, your skin goes back really fast right then.
Yeah. Can you tell, like, is there a method to discern whether or not they inherited those gametes that you're looking for, or is it just trial and error?
Yeah, I don't think that we've isolated a gene that we can tell if the gene is present and it's going to be 30 and calling it.
Okay.
But what we can do is once whatever, because there's always death in that process. So once the corals get big enough that they have survived in more than enough tissue, then we can take parts of those coral that have survived roots, and we can expose those to temperature and disease, and we can see which ones are doing better, and see if we can find the traits that have been combined correctly.
Cool. Well, that's awesome.
Yeah.
So, my other question to you is, so you've got a lot of scientific divers here, and obviously you're representing Mote. What makes Mote send somebody to, a symposium like this? Can you explain a bit?
Yeah, so it makes it AES, the American Academy of Underwater Science. It's a group of organizational members and individual members, and it makes it easy for organizations to send divers to each other, to other organizational members, while understanding that there's a certain level of professionalism and diver safety and diver quality. So it's really easy for one organization to say, hey, I've got this diver, and we're working on projects with you, I'm going to send you my diver. And then they can just easily have an piece of paper, and then they can dive to that group. They don't have to get all this information about liability and all their qualifications.
So basically, if you have that credential, it's assumed that the training is fairly universal and everybody understands what's going on. And
there's a set of standards and paperwork that every organization should have for their divers.
Well, I really appreciate it, Joe. Thanks for answering my questions. And yeah, I know that we'll see you guys soon.